And welcome back to Spacevidcast with amazing background music. I'm Tim Bailey here with Braun, Chief Technologist for NASA. So you guys, what is the Chief Technologist? That's a relatively new office at NASA, correct?
Yeah, well, there's been a Chief Technologist at NASA previously, but there hasn't been one in a decade, so it is relatively new. Our office is focused on the future. It's actually a great job. To be honest with you, I can't imagine a better job. Me and my team, we get to dream about the future all day long, and we get to start making the future a reality today. And we get to do that every day. It's great.
So when we talk about cutting-edge technologies or breakthrough technologies, if we wanted to say game-changing technologies, sure. Is that your realm of expertise, making the impossible possible?
Sure. I would think of it more as through. So it's not so much making the impossible possible, but what are the technological breakthroughs that we need to invest in today to make our future science and human exploration missions possible? You know, if you look at the Science Mission Directory, you take any of the decadal surveys that have been done by the National Academy, whether they're the planetary decadal or the Earth Science decadal or the astrophysics, there's some awesome missions in there, right? And all of those missions require investments in technology. Similarly, if you look at our plans for human exploration, to go out to an asteroid, to send humans one day to Mars, I mean, these are grand challenges.
Right.
And we're not going to be able to do those grand missions without some new capabilities, without some new technological capabilities. So my office is chartered with looking at all those mission plans and figuring out which technologies we should invest in today so that just a few years from now we're able to go off and do those great missions.
So what's the scale that you guys work? Are you in like a 2-year time cycle, a 5-year time cycle? I know it was amazing. Crescendo came up.
Yeah. Great sound.
The Twitch content is awesome. Have you been in there to talk to them?
Not this launch, previous launch, but yeah, I love it.
Sweeps are cool. So what is the scale that you guys work on? Because when I think of grand challenges, I think of, decades-long research. It's just very basic science. Are you guys more focused on the basic research or specific applied science fields that you're working towards?
So maybe the best part of the office is that we have a portfolio of technology investments that span a wide time frame. So we're investing in things that will happen actually next year. We have some flights coming up next year. We're also investing in things that are, say, 2 to 3 years out. And at a low level, we're investing in things that are maybe 10 or 20 years out. So we span the gamut. If you know NASA speak, we talk about TRL, technology readiness level. Technology readiness level of 1 is maybe like this morning, you might have in the shower, might have had a brilliant idea.
Right.
That would be a TRL 1, like just an idea, a concept, something that needs to be fleshed out in more detail. Something that we fly in space and prove that it works in the relevant environment of space is a TRL of 6. And something that we fly in our missions is a TRL of 9.
Wow.
So that's the scale, the spectrum. And my office focuses from TRL 1 to TRL 6, from idea to flight, taking things from concept all the way to flight.
So what are some of the things that you've got in the queue right now that are really awesome? Like what's going to catch people's attention and go, this is NASA on the cutting edge?
Yeah, so we've been working for the last year or so on a couple of pretty cool technologies. One is at the Marshall Space Flight Center right now in conjunction with folks at the Langley Research Center and companies from across the country. They're building composite cryogenic tanks, big tanks that could be part of the Space Launch System or some future incarnation of the Space Launch System. And these tanks, because they're made of composites, they're lightweight, so they save fuel, and they're low cost. They save us a lot of money on future systems. That's just one example. We're also working, the Langley Research Center and folks at the Wallops Flight Facility in Maryland are working on a concept for an inflatable aerodynamic decelerator. So you've probably seen these big capsules and things that come back from space.
Yeah.
They're pretty hard to launch because they don't package very well inside a slender launch vehicle shroud. But imagine folding up that entry body, compacting it like you would compact a parachute.
Okay.
And then once you're in space, inflating it and making it a blunt umbrella-like shape. That's called an inflatable aerodynamic decelerator. We're going to fly one of those perhaps next year on a sounding rocket test out of the Wallops Flight Facility. at hypersonic speed. It's going to go, maybe somewhere between Mach 6 and Mach 20, depending on the specific conditions.
And it inflates. Do you think that's going to actually hold up? Is that part of the test?
Yeah, did you ever see, was it 2010, the second in the 2001 Odyssey? When they had the Russians and the U.S. together going out to Jupiter. You might have noticed that when they got there, they braked into orbit with a large inflatable system. That's the kind of thing. This would be for space station downmass to bring cargo back from the space station. And a couple of the COTS providers, the commercial companies that are going to be bringing cargo back eventually from station, are interested in this technology. NASA's interested in this technology as well, so we're doing it together.
That's pretty cool.
Now, we're not going to fly the full vehicle next year. We're going to fly a test article, small-scale test article. It'll be about the size of this tent, actually, so it's pretty big, but not big enough for people or anything like that.
Right, but you take it to the point where you've flown it, you proved that it works.
That's right.
And then somebody else can pick it up from there and actually take it to usability and emission.
Yeah, what happens at NASA all the time is we have these great ideas for missions, but when you get the engineers in the room, they're a little, rightfully, they're a little risk averse. They won't fly those new technologies until they've been proven in space. So my office's job is to take those ideas, prove them in space, so that the future missions will then accept them and use them.
Very cool.
Yeah, it's totally cool. I love it.
Well, thanks for coming on for just a few minutes. I appreciate you taking out a couple minutes of your time.
Yeah, hey, thank you.
Thanks for all the stuff that you do to make the future happen. We appreciate it.
Yeah, well, that's what NASA's all about, right? Making the future happen.
That's what we think. Cool. All right, and we're going to toss it back to NASA TV for just a minute.